All right, welcome back, everyone. In this video, we're going to take a look at applying Laplace transform to exponentials. So, using definition of Laplace transform to evaluate some exponential functions like example A here, e to the negative 3t. Okay, so just to have ready for us to go, let's rewrite the definition of a Laplace transform. So, Laplace of a function f of t is the integral 0 to infinity e to the negative st times f of t d of t. Okay, so e to the negative 3t, that is going to be my f of t that I'm going to be plugging into this integral. So let's go ahead and get started with this Laplace transform. So Laplace of e to the negative 3t, well, that's the integral of 0 to infinity e to the negative st times e to the negative 3t dt. Okay, so let's see, we both have exponentials here, base e. All right, so one thing we could do since these exponents are being multiplied is we can add the exponents together, create one exponential term. So what this could become is the integral of 0 to infinity e to the negative st minus 3t dt. Okay, so this is all one term now, which is good for our integration. We want to clean it up a bit. And what we want to do is factor out a couple of things. We want to factor out the negative, and we want to factor out the t. We'll see why in a second, but we're going to factor it out like this. So this will be e negative s plus 3t. Okay, so what do? We factored out negative, and we factored out t. We want to clean, like s plus 3. Okay, we don't want a negative s for this situation. Okay, and we want to factor out a t so that the integration is a little easier. Because when we integrate, this is like another, you know, albeit odd, but this is actually a mental use of situation because negative s plus 3 is a constant. All right, so what this integration looks like is e to the negative s plus 3t all over negative s plus 3. And we're going from 0 to infinity. Okay, so like we do with these problems, we want to move down the negative exponent so that when we evaluate from 0 and infinity, it's easier to determine whether this function goes to infinity, goes to 0. All right, so let's go ahead and move that down. So this would be 1, well, let's move the negative outside. Negative 1 over, s plus 3 e to the negative s plus 3t. And we're going from 0 to infinity. And so when I plug in these bounds, what we get is negative 1 over s plus 3 e to the negative s plus 3 times infinity, a very long denominator. Let me move this 1 over, make it more appealing, minus negative 1 over s plus 3 e to the negative s plus 3 times 0. Okay, so what happened? Excuse me, when I move this down, the negative goes away. So let's erase all the negatives in the denominator. Sorry about that. We moved it down, so a positive exponent, but um, when I plug in infinity here, if s is greater than 0, this term becomes, let me write it over here, sorry. If this term, if s stays greater than 0, this term could turn into -1 over infinity. Because this could go to just infinity if s is greater than 0. And this whole term here, e to the s plus 3 times 0, well, that just goes to 1. E to the 0 is just 1. So I'm just left with -1 over infinity plus 1 over s plus 3. 1 over infinity just goes to 0. So this just equals 1 over s plus 3 for s greater than 0. Excuse me, not greater than 0. Let me backtrack a bit. This would be if s is greater than -3. Sorry about that. I was treating it as if it was just s, but yes, s plus 3, we need it to be positive. So it needs to be bigger than -3. And so 1 over s plus 3 for s greater than -3. So therefore, our solution is 1 over s plus 3 for s greater than -3. Okay, so that's example A. Let's go ahead and look at example B now. So example B is Laplace of e to the 5t. We got a positive 5t now, so let's see if this is a different setup. So this would be the integral of 0 to infinity, e to the negative st, e to the 5t dt. So same idea, we could combine exponents, so e to the negative st plus 5t dt. And I want a positive s when I factor. So what this would look like is 0 to infinity, e to the negative s minus 5t dt. And then same idea, this would be a mental u sub. Okay. And so this would be 1, excuse me, this would be e to the negative s minus 5t all over negative s minus 5 going from 0 to infinity. Okay, and same idea we've been doing. We want to bring down the negative exponent. Hopefully I don't write negative again. That would throw off our answer. So this would be, bring the negative out in front though. This would be, I want to write the denominator first. S minus 5 e to the positive s minus 5t all under 1, going from 0 to infinity. And so if I plug in my bounds, I get negative 1 over s minus 5 e to the s minus 5 times infinity minus negative 1 over s minus 5 e to the s minus 5 times 0. Okay, so if s is greater than 5, we want s to be positive, then this whole thing, e to the s minus 5 times infinity, goes to infinity. Okay, so if that goes to infinity, what I end up with is -1 over infinity. And then my right side term, this just goes to e to the 0, which is just 1. So what I'm left with is just positive plus 1 over s minus 5. -1 over infinity goes to 0. And so what I'm left with is just 1 over s minus 5 for, or I want to say 4. Let's say, you know, if s is greater than 5. So therefore, my Laplace transformation is 1 over s minus 5 for s greater than 5. Okay, so that is my solution and my two examples dealing with exponential functions. So same idea, definition, but we combine them into one exponential term, move the negative exponent down, and then deal with the infinity and zero bounds. All right, but same idea in solving these. All right, need s to be positive and for that infinity to go to zero. But that's it for this example. Thank you for watching, and I'll see you in the next one. All right, take care.